Hello there, so this video is for BTEC Applied Science and it's going to cover part of the chemistry specification for Unit 1 examined unit. So the specification is split into two parts. We've got two assessments. We've got assessment 1, which is structure and bonding in applications in science. We've already covered all of those so far in our lessons up till now. Hopefully you'll find some more videos on those useful coming soon. And the second assessment point starts with production and use of substances in relation to properties. It doesn't really give you too much information there until we kind of expand that out. And this is what we're going to focus on today. So we're going to look at periods 1, 2, 3 and 4 and what that means. We're going to look at groups. We're going to look at S block, P block, D block. We're also going to look at something called the F block, which isn't mentioned here. And we're going to look at the layout of the periodic table and using electron configuration as well. So you will be able to draw on some prior knowledge here from A1 when we looked at electron arrangements, when we looked at the notations for those, also most likely some knowledge that you'll have from GCSE with periods and groups. Okay, so there's a copy of the periodic table. There's an awful lot of information on there. It does look quite complex and complicated. However, when we kind of look at the different sections and groups and periods, we're going to work out what each of these things mean. So we're going to look at groups, periods and blocks. So we're going to look at what groups are, what periods are, the S, the P, the D, they were mentioned at our spec, and F block. So I've kind of tried to simplify the periodic table a little bit here by kind of drawing it into different coloured sections. So this relates back, if you want to rewind the video, you can take a look back at the actual periodic table. It was quite busy with all the information on it. Here we have, and I've colour coded these blue blocks. On the periodic table I showed, hydrogen was actually appeared here. Sometimes you'll see it hovering over here, sometimes you'll see it above here, and we can explain that hopefully in a minute. And also notice how this is coloured blue over here. So these blue elements are known as the S block elements. So these are S block. And the green block, which you can see is only on this section here. So all of these elements are known as P block elements. The elements all in this kind of pink colour here, all of these elements are D block. So we must recognise S, P and D. And the periodic table I showed also has a little section down the bottom here, and this is our F block. So those are our 4 blocks. Now, how we determine what block something is in is the electron configuration. So if you remember, when we looked at electron configuration last term, we no longer used, for example, at GCSE, the electron configuration for carbon. Carbon had 6 electrons. We would just say the electron configuration was 2, 4. And that meant it had 4 electrons in the outer shell and it had 2 shells. Okay? But we went one step further. We would actually call that 1s2, 2s2, 2p2. And we're going to do a little bit of revision of this in a moment. So that's how we did the electron configuration. We moved it from GCSE up to our level 3, 1s2, 2s2, 2p2. So I can see, looking at this, it is a P block element because the outermost electrons are in the P subshell. So anything that appears here, the outermost electrons are in the P subshell. Anything that appears in the S block, that's because its outermost electrons are in the S subshell. And that's why helium appears up here, okay? Because helium actually has 2 electrons, has the electron configuration 1s2. So its outermost electrons are in the S subshell, which means it's an S block element. However, the reason it appears at this end of the periodic table is because it is in fact full shell. So it has a full shell, so it belongs with our noble gases. And all of these are classed as our noble gases because they have full outer shells. Most of our noble gases are P block elements. However, helium is an S block element. So look out for that one there. And again, anything that appears in the middle in the pink, the outermost electrons are in the D subshell And yes, there's a shell that we haven't talked about and that you won't talk about, but I'm mentioning it here. Anything that appears down here has electrons. The outermost electrons are in the F subshell. Okay. Okay, so what you're going to do now is I'm going to ask you to identify which block these elements are in. So you're just going to identify each of these elements as either S, P, D, or F elements. In order to do this, you will need a periodic table and you will be supplied with one in the exam. Hopefully you have a paper-based one that you can use. If not, use a web version. So pause the video now, and when you think you've answered all 10, once you've identified the blocks, unpause the video and we'll go through them. Okay, we've identified lithium as an S block, carbon as a P block, manganese is D block, aluminium is P block, tungsten is a D block, radium you'll find at the bottom and that's an S block, cesium, Ce, you will find that's the F block, iron is D block, hydrogen is S block, and helium was S block. A little bit tricky those two because they tend to float in unfamiliar places. Okay, next thing we're going to look at then is we've identified blocks. We now know that we've got some S, P, D, and the F block. We're now going to look at groups and periods. Now, when it comes to period, the period is the row. So the first row is period 1, so that's the first period. There's only 2 elements in the first period. Quite often people, especially when hydrogen doesn't appear here, if it appears here, it's quite a common mistake for people to think that this is the first period, when in fact it's not. This is the second period. So look out for that mistake. Don't make that one, okay? First period is the first row, which only contains hydrogen and helium. The second period is the second row, and then third period, fourth period, fifth, sixth, seventh, and so on and so on and so on. Okay, so that's what the period means. It actually relates to the number of shells. So if you've got 2 shells, you're in the second period. If you've got 5 shells, you're in period 5. Okay, and when it comes to identifying groups, group 1, group 2, we don't have a group number for the D block. And then we come to group 3, 4, and so on until you get to group 8. Sometimes though, this is called group 0 because this is our noble gases where they've got a full outer shell. So this can be called group 8 or can be called group 0. Okay, so another task now. So what you can do this time is for these 10 elements, you're going to identify the group number and the period number. Okay, so you're going to identify which group it's in and which period it's in. So pause the video now, and when you're ready to go through them, unpause. Okay, so I'm going to identify the group number and the period number. So I'm going to give you 2 numbers. Lithium is group 1, period 2. Remember, be careful with lithium. Sometimes people think it's period 1 because of the periodic table they're looking at. Hydrogen might appear that it's not period 1, so lithium is period 2. Carbon is in group 4, period 2. Aluminium is in group 3, period 3. So we're identifying group number is the number of outer electrons, period is the number of shells. But we can identify this purely by looking at the periodic table. Potassium is in group 1, period 4. Tin is a little trickier. Tin is in group 4, and if we count the periods down, it's 1, 2, 3, 4, 5. It's in period 5. Cesium is in group 1, and the period 1, 2, 3, 4, 5, 6. It's 6 rows down. Lead is in group 1, 2, 3, 4, 5. It's 5 along. Oh, it's 4 along. Sorry, my apologies. It's 4 along, and the period is 1, 2, 3, 4, 5, 6. Argon is in group 8 or 0, I'll accept either or, and it's in period 3. Hydrogen, group number's funny here actually, which is why it tends to float, but I'm going to say group 1 because it does have 1 electron in the outer shell. The reason you'll see it floating is because it doesn't belong with the metals, because it's not a metal. But hydrogen, we're going to go with group 1, period 1, and this is where helium's awkward, because we are going to call it, that's why we'll call it group 0. Now, if you call it group 8, I think we can allow that, but group 0 is why you tend to have that 0, because helium doesn't have 8 electrons, it's got a full outer shell. So group 8, group 0, we'll accept there, and period 1. Okay, final section for this video then. We're going to look at electron configuration, or reminders of the shells. Okay, now the lowest energy shell was 1. The first shell is 1, and it only contains 1 orbital, so 1s. It can hold 2 electrons. The second shell can hold up to 8 electrons, and it has a 2s, and 2p, and the p has 3 orbitals. So this hopefully is revision, but I'm going through this just to remind us. Then the third shell, 3s, but it has a 3p also, which is just slightly energy. We also have the 3d, which can hold up to 10 electrons at 5 orbitals. And then, annoyingly, the fourth subshell was actually overlapped. It came below the 3D but above the 3P, okay, which was a bit awkward. And then we have the 4P. So this was in terms of order of energy, in terms of the order in which they fill. So if we want to look at an element, let me pick a random element from the periodic table, calcium. Calcium has a mass number of 40.0 and has 20 protons. So the electron configuration of a calcium atom would have 20 electrons. So I'd put 1, 2, 3, 4, 5, 6, 7. Remember, these orbitals fill separately first. There we go. We've got 2, 4, 6, 8, 10. I'm still got 10 to go. 1, 2, and 2. That's 18 electrons, 19, 20. So the electron configuration for calcium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. That would be calcium. And you may need to look back on some previous videos to remind yourself of doing a few more examples, but I'm going to give 2 more examples here. I'm going to give us iron, which has 26 electrons. So for 26 electrons, there's an extra 5, and there's 6. Okay, so there's our 6 electrons, or 26 electrons. So it would look very similar to calcium in terms of 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Okay, and next thing that we look at is when we remove electrons to become ions, or when we add electrons to become ions. So if we were to look at something Fe2+, now Fe2+, this is where we had to be a little bit careful here, because Fe2+ means we've lost 2 electrons, but you don't take them from the 3D first. We take them from this 4s first. This was the annoying thing. So we would lose these 2 electrons for iron 2+. So iron 2+ would be 1s2, 2s2, 2p6, 3s2, 3p6, 3d6. That's really awkward when it comes to the electron configuration of ions, particularly when you're up into the 3D and the 4s. Something like calcium 2+ would be much more straightforward. With the calcium 2+, let's just remind ourselves of what the electron configuration was. Calcium atoms, so we didn't have any of these 3D electrons, or the 4s, or the 3p. It finished with 3s2. So these are far more straightforward. So calcium, to become calcium 2+, it does just lose the outer 2 electrons there, those 4s. So calcium 2+ is 1s2, 2s2, 2p6, 3s2, 3p6. Okay, it's only those awkward ones once you've got those 4s orbitals. So you've got to look out for that. If your 4s orbital has been filled, because your 4s orbital will fill before 3D, but also when you form ions, the electrons will be lost from the 4s before the 3D. So that's just something to look out for. Okay. Anything below, and it's just the same rules, you would just remove from the outermost. There's nothing awkward about those. So what you're going to do now is you're going to pause the video and you're going to do the electron configuration for these 10 elements or ions. So the last 4 are ions, and you're going to have to be a little bit careful about how you do those. So pause the video, and when you're ready, unpause it, and we'll go through them. Right, lithium. So looking at the period. Hopefully you found this useful then. If you have, please do let me know. I'm very happy making more of these for all the other topics that we're about to cover, and obviously topics that have been covered in the A1 learning aim. And also we'll do the same with some physics and biology, and possibly even with the control assessments as well.